Let us try to understand question number 7.70 of NCRT, which is from the chapter Chemical Equilibrium and is based on the concept of ionic equilibrium and use of concept of solubility, solubility product, and ionic effect, common ion effect. The question says that the ionization constant of benzoic acid constant of benzoic acid is 6.46 10 to the power minus 5, and solubility product, that means the product of the concentration of silver ion and benzoate ion, is 2.5 10 to the power minus 13. Now there are two conditions. Silver benzoate is dissolved in water and silver benzoate is dissolved in benzoic acid. So we have to find out that in which case the silver benzoate is more soluble, whether it is soluble more in water or more in benzoic acid with a buffer of pH 3.19. So what we have to calculate is, we have to calculate the solubility of silver benzoate in water to that of solubility of silver benzoate in benzoic acid. Now this problem statement gives us a number of values. It is given that ionization constant of benzoic acid. Now ionization constant of benzoic acid is nothing but acid dissociation constant. So how do we write acid dissociation constant? The acid here is C6H5COOH. Since it is an organic acid, it will not dissociate to the fullest extent. It will form C6H5COO minus and H plus, such that its Ka, that is concentration of C6H5COO minus into concentration of H plus divided by concentration of C6H5COOH, and this value is equal to 6.46 10 to the power minus 5. Also it is given that when silver benzoate is dissolved in water, when silver benzoate C6H5COO minus Ag plus is dissolved in water, then it forms C6H5COO minus aqueous plus H plus ion aqueous, such that the product of the concentration of C6H5COO minus into I repeat, C6H5COO minus into concentration of Ag plus, this is Ag, is equal to a given value 2.5 10 to the power minus 13, that is KSP is equal to 2.5 into 10 to the power minus 13. So when C6H5COO minus Ag plus is dissolved in water, then it breaks into C6H5COO minus aqueous plus H plus aqueous. So when no water was added, at that time its concentration was 1 part by 1 part, and when water was added, then from the 1 part X part came out, so it formed X part and it formed X part. So if X is the solubility of C6H5COOH and X is the solubility of H plus here in saturated solution, then this implies C6H5COO minus into H plus is equal to X into X is equal to X square, and the value of this is given to be 2.5 into 10 to the power minus 13. To make our calculation easy, we will consider X square is equal to 25 divided by 10 can be written as 10 to the power minus 14, such that X becomes root of 25 will be equal to 5, and square root of 10 to the power minus 14 will become 10 to the power minus 7. As easy as that, half part of the problem is done. Now rest half part of the problem is that when in the vessel of benzoic acid C6H5COO minus, earlier C6H5COO minus and H plus was there with a pH is equal to 3.19 is given here. Now when silver benzoate will be added, then due to this benzoate ion, this equilibrium will shift backward and almost no benzoate ion will be left, as a result of which we can write that concentration of Ag plus will be equal to concentration of C6H5COO minus into concentration of C6H5COOH. The value of this is partially given in an indirect manner. We can find it out by little bit of calculations. We have been given the value of pH is equal to 3.19. This means minus log concentration of H plus ion is equal to 3.19. This means log concentration of H plus is equal to minus 3.19, or we can write concentration of H plus is equal to NT log 4 bar plus 4 minus 3.19. This is how we find out NT log, and this value comes out to be 4 bar 81. If the value of 0.81 is found out in log table, then value comes out to be 646, and we put one decimal here, 6.46, and this is written as 10 to the power minus 4. So this value we can remember as concentration of H plus. Also it is given that value of Ka is C6H5COO minus and H plus divided by C6H5COOH, such that the value of Ka is 6.46 10 to the power minus 5 is equal to, we can put the value of H plus, we can put this value of H plus in place of this, so this will become C6H5 COO minus by C6H5 COOH, and H plus can be brought in the denominator here as 6.46 10 to the power minus 4. So we can write this relation as C6H5 COO minus is equal to C6H5 COO H by 10. This value comes out to be 1 by 10. Or C6H5 COOH is equal to 10 times of C6H5 COO. We can use this equation here. So there was a plus sign here which we missed out, so this plus sign should be here. So concentration of Ag will be is equal to C6H5COO minus plus 10 into C6H5COO minus. So Ag plus will be equal to 11 into C6H5COO minus multiplying Ag both the sides, it will be 11 into concentration of C6H5 COO minus into concentration of Ag plus. So value of this much is given. Let the value of this be equal to y and value of this be also equal to y. Obviously will become 11 into the solubility product of these ions, 2.5 10 to the power minus 13. So we can write y square is equal to 2.75 into 10 to the power minus 12, or y will be equal to, if you consider this as 3, then around 1.7, but if you find out the square root properly, it will come out to be 1.66 10 to the power minus 6. This y is nothing but the solubility of silver benzoate in benzoic acid. Hence, solubility of silver benzoate X in water and Y in acid will be equal to 5 into 10 to the power minus 7 by 1.66 10 to the power minus 6, or solubility of silver benzoate in the given acid divided by solubility of silver benzoate in water will be reciprocal of this, and the value of will be 3.4. Therefore, solubility in acid will be 3.4 times.